All right, so let's go ahead and look at this second example here. And I'm going to call this first plane its normal vector n1 again. And that's 1, 2, 2. And then for the second plane, its normal vector is 2, negative 1, 2. So again, the first question is, are these planes parallel? And to show that, we ask ourselves, is one of these normal vectors ni equal to a scalar multiple of the vector nj? So that's what we're asking ourselves. Now let's take a look. Can I multiply 1 by something to get 2? I can. I can multiply this by 2. Let's see if this holds still for the y and z component. Can I multiply 2 by 2 to get negative 1? Unfortunately, I cannot. So these values all need to be multiplied by the same number if they were to be a scalar multiple of each other. And in the other way, it wouldn't work either. Multiplying 2 by 1/2 would give you 1, but multiplying negative 1 by 1/2 does not. Oops, I shouldn't have put that. A positive 1/2 does not give you a positive 2. So these are not scalar multiples of each other. Now, in the interest of space, I'm going to move this right below here. All right, so now we get to ask ourselves the second question, and that is, are these planes orthogonal? In order to show that, let's take the dot product of these vectors. So in essence, what we're really asking ourselves is, does the dot product here equal 0? All right, so let's take a look. That's equal to 1, 2, 2, dot 2, negative 1, 2. So this is 2 minus 2 plus 4, and that is certainly not equal to 0. So these are not orthogonal. All right, so now let's find the angle between these two planes. And I'm going to make a little extra space again. So we're asking ourselves, what is the angle between these two planes? Okay, so the angle between these two planes, theta, is given by the arc cosine of the dot product of their normal vectors, which we already know is 4, times the magnitude of each of these vectors, that is the product of the magnitude of each of these vectors. Well, we just need to work out the magnitude of each. The magnitude of n1 is equal to the square root of 1 plus 4 plus 4, so that's 9. So 3, and the magnitude of n2 is equal to what? 4 plus 1 plus 4, and again, that's 9, the square root of 9, so this is 3. So theta is equal to cosine inverse of 4 over 9, and this works out to be about 63.6 degrees. So they intersect, and the angle between them is 63.6 degrees. I hope you found this video helpful.